Hello, physics. So this is a question from static electricity. And question one, state Kirchhoff circuit rules. Number two, a circuit is given, three resistors in parallel, two EMF, and one ammeter in a series with R2. This is R1, R2, R3. This is current I1, this is current I2, and this is current I. It says that ammeter has small resistance by comparison of the other resistors, and it reads 3M. That means I is 3M. Find I1 and I2 and EMF. Calculate total power in three resistors. Number four, XY, this X and Y point. Conductor length is given, which is a 0.12 meter, 12 centimeter. The electron leaves a drift velocity. Vd is given 2.80 into 10 power 4 meter per second. And number density is N, 8.49 into 10 power 28 numbers carriers per meter cube. Calculate the resistivity of the conductor X and Y. So question number one, state the Kirchhoff rule. So Kirchhoff rule is the junction sum of the all currents, J currents and J currents in and out are equal. So junction rule, the sum of all the current entering any junction must be equal to the sum of the currents leaving the junctions. So this is conservation of charges. Number two, the voltage rule. The sum of the potential differences across all the elements across the closed circuit loop must be equal to zero. So all the voltages on the all devices should be equal to zero. So this is first part. Second, this circuit is given. This is loop one, this is loop two, and this are counterclockwise movement. So we're going from negative to positive on this one, and this one also positive to negative, like this one. So at junction x1, so all the current should be equal to zero. So current I1 is coming, I2 is also coming. I1 all plus I2 is equal to I. So I is this one, this is which is leaving, which is I. So equation number one, voltage in any loop one. So this one counterclockwise. So this will negative to positive, positive. So and then over movement is this way, and the current is also this way. So this is negative 7I1. So this one is also 7. We moving this way, and the current is moving this way. Minus 2I. I is equal to 0. Equation number 2. Number 3, loop 1 and loop 2. Loop 2, so from this one negative, we are going so it's negative 15, and then we are going this way, and this is opposite. So this is a 2 resistor and I, and then this one 5 I2 is equal to 0. Equation number 3. So now we have to simplify. So there are 1, 2, 3, 3 unknowns and 3 equations. So I is given. So equation 2 and equation 3, add them together. So if we add them together, so this one will be cancelled. So will be cancelled. So we will get EMF minus 7I1 plus 5I2 minus 15 is equal to 0. Equation number 4. I is given, which is in the statement. So I1 plus I2 is equal to 3. So this is equation number 4. Equation number 5, this one substitute in this one. So this is minus 15, and then the value of I1, equation number 5, this one in equation number 3. Yes. So this is a 3. This I1 plus I2 is equal to I. So this is equal to equation number 5. Equation number 5 will go to equation number 3. So equation number 5, which is this one, it will go to equation number 3. So this one is equal to minus 15 and 2i, 2 into 3 plus 5 into I2, which is equal to 0. So this one is equal to, actually, it should not be 5. This should be this one, this equation. So minus 15 plus 6 minus 9 plus 5 I2. So I2 is equal to 9 over 5, which is equal to 1.8, or 2 sig fig 1.80 amp. This is the first one. And substitute this value into equation number 3. Equation number 3 is 3. So I1 is equal to I minus I2. I is equal to 3 minus 1.8 is equal to 1.20 amp, which is the second result. So if you substitute in equation number 4, which we have this one, so EMF minus 7, I1 is 1.2 plus 5, I2 is 1.8 minus 15 is equal to 0. So EMF is equal to 14.4 volt. So this is the another answer. So all the unknowns are now known. Next one is power. Power in the circuits, in the circuit. So I square R. So this one is R1, R1, R2, and this is R3. So I1 R1 plus I R square R2 plus I2 R3. R1 7, R2 2 ohm, R3 5 ohm. If you substitute the value 1.2 amp square multiplied by 7, this is 3 amp multiplied by 2, and this is 1.8 square multiplied by 5, and total is 44.3 watt, which is the power dissipated in the circuit. Next one is find resistivity. Resistivity is equal to rho is equal to R L over R A over L. So here A we have to find. A will be equal to in the form of drift velocity. Drift velocity is current divided by number of density into number of charge, value of charge multiplied by area, cross section. So from here, cross section is equal to current divided by number density into charge into VD. So substitute this value here. So that will be equal to R into I, N, value of a current, value of the charge, multiplied by V, drift velocity into L. So R is 2 because it is in this X and Y conductor, and its length is also given. So R is 2, current is 3 amp, number density is 8.49 into 10 power 28 per meter cube, and the charge is 1.6 in 10 power minus 19 coulomb, and drift velocity is 2.8 10 power 4 meter per second, and the length is 12 centimeter 0.12. So if you multiply this one, its answer is 1.314 into 10 power minus 5 ohm meter, or in 3 sec fig 13.1 micro ohm meter. So this is the answer. So this is a slightly complicated but good question.